Calorimetry is the most important practical skill of this unit, practical concept. It is all based on the conservation of energy, which simply put says that whatever energy you start with, you're going to finish with. So when you identify an example as being a calorimetry type of question, then we're going to start with the idea that heat lost equals heat gained. And you can put that down as however you like. It can be HL, HG, EL for energy lost equals energy gained. Delta H equals Q is even appropriate, although I prefer heat lost, heat gained. Most importantly is to recognize it, like any other type of question. So to be calorimetry, you're going to have at least one substance dissolved in one other one with a corresponding temperature change. You have that one substance in something else with a temperature change, you know your calorimetry. Let's work through an example. So, I'll cover up my solution here. So we see we have our sodium hydroxide dissolved in water, resulting in a temperature change. Okay, so right away, I know I must have a calorimetry scenario. So how do I start? Well, I've got my heat lost equals heat gained. Okay, it doesn't matter if you have Hg equals HL or whichever order you put, as long as you have something there. The next step, and this is probably the most important one, because this really keeps your variables aligned with the right side of your equation. Identify what's gaining, what's losing the energy. The water is the easiest to identify because it's what's changing temperature. So I've increased by 12¼ degrees, so the water must be gaining energy, and the sodium hydroxide is losing because it caused that energy change. Next thing we're going to do is identify the type of energy that we're dealing with. Well, again, let's look at the easier ones. Temperature change we know is kinetic. And what's going on undergoing a temperature change? The water. So the water is EK. The sodium hydroxide just says it's being dissolved. It's not changing temperature, so it's just a reaction, in this case physical reaction, so it's potential. Remember, any nuclear, physical, chemical reaction are just potential energy. It's only the surround to change temperature. Then from there, we can go right into our formulas. Okay, we've got potential energy equaling N delta Hm, kinetic energy equaling MC delta T. Whether you're using unit analysis or formulas, your units are key. So please do not forget to work with your units. Don't take shortcuts with them. It's a very easy way to trick you up. So I've just plugged in all the numbers here. Okay, rearranged first to solve for my delta Hm, so it's MC delta T over N. Plugged in all the numbers that I have. You'll notice that 1 mole over 40 grams over here. That's just the molar mass of sodium hydroxide. We work all that out. We get 6,844 joules per mole. Now, two things, we're not quite done yet. First off, according to my question, I can only have 3 significant digits, so I have to simplify that. And also, it's exothermic. So when you're calculating molar enthalpy or enthalpy changes, you have to indicate whether the system is exo or endothermic by incorporating a sign. Since it is exothermic, energy has been released, we're going to put a negative down. This is negative 6.84 kilojoules per mole.